First problem asks us to find the equation of the plane tangent to this surface at this point. And so based on the way this is given, since it's not solved for z, you could solve for z, but that's going to give you a quotient, and you have to apply a quotient rule, which I don't want to do. But I can use the shortcut that says that I'm just going to define this as f of x, y, z equals 0, where that just means I'll bring this over and this becomes my f. Oops, plus 1. So this is my f. Once I get it in that form, then the equation of the tangent line turns out to be my partial with respect to x at my point 1, 2, minus 1 times x minus the x coordinate, partial with respect to y at 1, 2, minus 1, y minus the y coordinate, and the partial with respect to z at 1, 2, minus 1, z minus the z coordinate equals 0. So I just need these partials. Well, each of these isn't too bad. This first partial is going to be, the partial with respect to x is going to be y plus z. And then again, I'm going to evaluate that at 1, 2, minus 1 times x minus 1. This partial with respect to y is going to be x plus z. Again, evaluated at 1, 2, minus 1, y minus 2, and then x plus y would be my derivative with respect to z, evaluated at 1, 2, minus 1, z plus 1 equals 0. And so just plugging in, I'm going to get my coefficient. This will be y plus z is going to be 2 plus a negative 1. That's going to be 1. So 1 times x plus 1, x minus 1. Squeeze it in there. Here I'm going to add the x and the z, and I get 0, y minus z, and then add the x and the y, and I get 3 times z plus 1. And you can multiply this all out to get, on the x, you'll have 1 times x, you'll have x, and of course, my pencil quits writing. As soon as it comes back on, we will try again. Do it with my finger. So you get x and then 0 on this second term, and what I've written here is y minus 2. That looks like a z. I think I said z probably when I wrote it too, but that's y minus 2 here. But anyway, it's 0 times that, so it doesn't mess with anything. And then 3z. Sorry for the sloppy writing, but I'm using my finger. And then what I've got left is I've got a minus 1, that my constants, minus 1 and a plus 3. Well, that'll be a plus 2, and if I bring it to the other side, that's going to be negative 2. So hopefully I didn't get too distracted on that. All right, so that would be the equation of that tangent plane. This next one, it's going to require the chain rule. So I've got a new pen now. So anyway, I know I want to take the partial of big A with respect to little a. That's going to be, well, I look at what big A is made up of, k, m, and n. So I'm going to take the partial of big A first with the first variable I see, which is k. And then I'll have to take the partial of k with respect to little a. Then add in partial of a with respect to m, and then partial of m with respect to a, and then the partial of a with respect to the last variable, which is n, and the partial of n with respect to a. So I just go find each of these partials. So the partial of a with respect to k is just going to be e to the mn. That's a constant as far as that goes. Derivative of k is 1. Partial of k with respect to a is just going to be bc. Again, b and c are constants, so you just partial of a is 1. Next, partial of a with respect to m. So this time we can see that m is up in the exponent here, so I have to use my chain rule for e. So I'm going to have my k, and I take the derivative of e to the mn, and I'll get e to the mn, and then I have to multiply by the partial of mn with respect to m. So that's going to give me partial of mn is going to give me an n, and then like I said, I'm going to have this other term that is just e e to the mn. So it's the derivative of e to the mn, and then multiply by the derivative of mn with respect to m. Sorry, I'm still having pen troubles. I'm switching them back and forth. Next, take the partial of m with respect to a. Again, it's up here in the exponent. So you take the derivative of e and you get e, put this inside function back in, and then the derivative of this abc with respect to a is going to give me bc, and then like I said, I'll still have my e to the abc. And then finally, take the partial of a with respect to n. Well, that behaves just like the last one. So I'm going to have my k, and then derivative of e to the mn is going to be e, put the inside function in, and then the derivative of mn with respect to n this time is going to give me an m, e to the mn. So there's my partial of a with respect to n, and then I take the derivative of n with respect to a. Well, it's like 1 over a, and the derivative of 1 over a is minus 1 over a squared. You can get that by writing it as a to the minus 1, and these are constants, so this is going to be minus bc over a squared. And then I was told I could leave it in mixed form, so there's my, I'll just leave it like that. That'd be my derivative.